part 1, which is electric charges and fields. But first of all, let me take you all through the journey of your part 1 and part 2. If you will see in your index of part 1, first 3 chapters will be of electrical physics, and from the 4th to 6th it will be magnetism or magnetic physics. Then the 7th chapter will be on AC currents, and the 8th chapter, which is electromagnetic waves, which is the combination of electrical physics and the magnetism or the magnetic physics. Then if we talk about part 2 will be having 2 major sections. The first one is about optics and the second one is about quantum physics, which will be dealing with atoms and nucleus. Your 9th chapter and 10th chapter is totally based on optics. 11th chapter will be the dual nature of matter and waves, right, which is the combination of energy of photons and something like that. Then if we will move to 12th chapter and 13th chapter, they will be atoms and nucleus. They are dealing with energy of electrons, orbital energy, so and so. And the last chapter is the 14th one, which is semiconductors, right? You must have seen those circuits, the green one having black dots, having gray dots on that in your calculator, in your mobile phone. So those are the semiconductors. So if we talk about whole physics in general, it is dealing with electrical physics, it is dealing with magnetic physics, then it is dealing with the combination of electrical physics and magnetic physics, which is the chapter 7 and chapter 8. Chapter 7 has nothing to do with magnetic physics. It is totally based on current and waves and sinusoidal form of current and so and so. And the second part is dealing with optics and quantum physics. Quantum physics is something when we deal with particles or the micro level physics, right? So now, if we talk about the first chapter, which is electrical charges and fields, let us first understand that what is electrical charge and what is electric. So let me tell you, before Christ 600, which is 600 BC, there was a scientist called Thales in Miletus in Greece. If you read the science, no, each and every word has the roots in Greece or the Greek language. So the word electron or the word electric or the word electricity comes from the Greek word electron, right? Electron. 600 BC. BC is before Christ, right? So this is too old to understand, too old to judge, to interpret. So moving ahead, you must have experienced that when you go near, go towards the TV, towards the PC, you must have felt an attraction. You must have got goosebumps, right? When you go towards PC, when you go towards the screen of your television, you must have felt a kind of goosebumps, which shows there is something which attracts your skin, right? You must have done that experience in your childhood, that when you rub a plastic scale in your dry hair and then take that plastic scale to the pieces of paper, it will simply attract the pieces of paper, right? Something like that. If I tell you, if you rub rod of the glass on the silk cloth, suppose this is a rod, and you will rub on silk cloth and take that glass rod near to the another rubbed glass rod, which is also being rubbed on a silk cloth. Suppose this is a glass rod, this is also a glass rod, and I have rubbed both the glass rods on a silk cloth. Then I am taking these 2 glass rods nearer to each other. It will repel each other. It will repel, right? And if I take one of the glass rods to the pieces of paper or to something else which is carrying negative charge of the glass rod is carrying, it will attract it. So from these experiences we can judge There are two type of forces. The first one is repulsion, or we can say repulsion, and the second one is attraction. Right? So when you rub something, due to the friction of between two objects, the charge is being transferred. If we talk about the case of glass rod, when you rub glass rod on a silk cloth, the charges was being transferred from glass rod to silk cloth. Let me show you. Suppose this is a glass rod. Suppose this is a glass rod, and I have rubbed this glass rod on a silk cloth. So what happened? Charges from this glass rod was being transferred to silk rod, and when I say charges, there should be a strike in your mind that I am talking about electrons only. Electrons were being transferred from glass rod to silk cloth. That's why you must have studied in chemistry that the object or the matter or the atom who left or who gave the electron to the another body, to the another object, it will become a positive one. The one who gives the electron becomes the positive one. So here in our case, glass rod gave the charges to the silk cloth. That's why our glass rod will become positive so far as charge is concerned, and our silk cloth will become negative. Right? Same thing happens when you rub plastic scale. Suppose this is a plastic scale and you are rubbing it on your dry hair. So due to the friction, what happens? The charge is being transferred from your dry hair to the plastic scale. So suppose this is a plastic scale and this is the pieces of paper. Right? And this is your dry hair. So what happens? Charges being transferred from your dry hair to the plastic scale. So your dry hair will become positive in charge, and the scale which is getting the charge, which is getting the electrons, that's why the scale is becoming negative in charge. Right? Now you must be wondering who named the charges positive and negative. So the scientist named this charge is the scientist called Benjamin Franklin. It is given in your textbook if you will read it. Then Benjamin Franklin gave the names positive charges and negative charges. So the electrons are being called negative charges and the protons are being called positive charges. Right? So in the case of plastic scale, dry hair will become the positive ones and the scale will become the negative ones. Now what will happen if you will take the scale to the nearer to the pieces of paper, then it will simply attract the pieces of paper. Right? So what does this show? This shows that due to rubbing or friction, due to rubbing or friction, there must be something which is happening. There must be the transfer of charges from a body to the another body. And due to this transfer of charges, what will happen? The bodies get charged. Whenever you will be going or you are going nearer to your television and you are getting goosebumps or you will feel a kind of attraction, no? So what does it show? It shows that your screen, your television screen is charged already, and your skin is being charged as well due to your sweat. Because if you know, our blood has the electrons. Our blood is the conductor. What is conductor? We will see further in this video. But our blood has electrons, and those electrons come out with our sweat. And you must have seen that in some of the movies that salt water is a conductor of electricity, Three Idiots, if I'm not wrong, right? So moving further, what we have understood in this topic, there are two kind of forces due to the presence of charges. One is repulsion, one is attraction. If the charges are negative and positive, first one is negative and the second one is positive, then this will be considered in attraction, right? But if both the charges are same, positive ones or negative ones, then there is a repulsion between those charges. But if the charges are opposite ones, no, positive negative or negative positive, then it will attract each other, right? So what we can do to check whether the body gets charged or not, whether this object, suppose this is a rod, this is a glass rod, and I want to check whether it gets charged or not. So there is an apparatus called gold leaf apparatus. What gold leaf apparatus does, it simply checks or it simply tells us that whether the rod is getting charged or whether the rod got charged or not. Apparatus is something like that. Suppose this is a glass box. Right? And in this glass box there is a hole and we are entering metal rod. And we know that metal is a conductor of electricity, right? And we are putting a leaf type, this type of golden leaf. This type of golden leaves, like this, connected from the end and like this, right? So we will put this leaf around here. Now what will I do? I will take the glass rod which is already being charged and will make it touch to the metal rod. What will happen? We all know that it is carrying positive charge. Now what will happen, due to the physical contact, this charge will get transferred to the metal rod and those positive charges will go on that leaf. Now let me zoom it for you. What will happen, this leaf has positive charge on both the sides. So both the side will repel each other, right? Not attract, it will repel each other. So if you will see the repulsion in both the sides of the leaf, then you can make out that the charges on both the side is same and our glass rod was being charged. It is a charged body, right? So you can find out with the help of this gold leaf apparatus that your body or glass rod or any object you want to check whether it is charged or not, you just have to connect it with this metal rod and you will be seeing that with the help of this golden leaf whether it is being charged or not. Got it? So it is all about the check or the checking of the presence of charge on that particular body. Right? Got it, guys? We have seen about the process of checking the presence of charge on any body. Now if you have observed that I use the word conductor, I told you that we are taking metal rod and most of the metals are good conductor of electricity. Now the word Conductor. What does this word mean? Conductor means which is the carrier of electrons or which can pass the flow of electrons easily. You have studied that all the metals are having free electrons, or all the metals are having 1 or 2 or 3 electrons in their outermost orbits in your chemistry, right? So what will happen in metals? Those electrons are behaving like the free electrons when they are getting energy from the light or from the any outer source, right? So they are free to move. Suppose this is a metal or this is a rod of copper, and all the electrons are free to move inside, which are in the outermost orbit. No, they are free to move inside the body. Now what will happen when you are connecting, or when you are rubbing, or when you are giving the force, which is EMF, electromotive force? We will be studying this in chapter 2 and 3 further. So when you are giving EMF to this body, all the electrons will be aligned in a direction and move in the single direction. They will run literally in a single direction, right? And that run or that flow is being called as current. So conductors are the metals or the object which can or which let the current, the flow of electrons pass throughout them, right? As for example, if we talk about copper is a good conductor of electricity. Then silver is better conductor than copper, but we cannot use silver in our daily circuits, right? And you know the reason. Now the second thing is insulator. What is insulator? Insulator is something which cannot let, or which don't let the current or the flow of electrons pass throughout them. Reason is, you have studied that as well in your chemistry, that non-metals are having 5, 6 or 7 electrons in their outermost orbits. So they can't, or they don't let those electrons go out of that body or out of those orbits due to the lack of electrons, because they require electrons. There is a shortage of electrons in non-metals, so there will be no free electrons. There will be no free electrons in insulator, and due to the shortage of electrons, they are not allowing, or they are not letting the flow to pass, because there is no flow. If you are giving EMF, if you are giving potential, if you are giving force to the insulator, if there is no free electron, then who will run? Who will run? If there are no athletes on the ground, then there is no race, right? Same here, there are no free electrons, then who will run when you apply the EMF, when you on the switch, right? So the basic and the major difference between conductor and insulator is all about the availability or the presence of free electrons. If something is having free electrons in their own bodies, they will allow to pass the flow due to the EMF, due to the potential energy. But if they are not having free electrons, then there is no question in passing the current or making a run, making a flow of electrons, right? So metals are being called conductors, and non-metals and something like plastic, rubber, artificial things are being called insulators. Got it? What we have studied today? We have studied about the rubbing of two objects and getting the body charged with the help of friction, right? Then after we have studied that how we can check the presence of the charge or whether the body gets charged or not. And then after we have studied about the basic perception of conductors and insulators, right? I will be putting the videos related to the next concept, all the chapters of your physics, of maths. So please share this video with your friends, right? So they can see and they can understand the realistic concept. And if you are having any doubts related to this video, then let me know in the comment section. Thank you.